Hello and welcome to the channel. So when I first got my Walco CNC mill, I decided that for a small little side project I'd make this little fly cutter, and this little fly cutter works amazingly well. It's got a 20mm shaft for an ER32 collet, and I use a carbide insert tooling from the lathe, which is held in place with these 3 set screws. And I get some really good finishes with this, but it's a little bit small and I don't really want to use an ER32 collet to put this into. So now I've got a proper mill, I want to make a proper fly cutter. And I've got this 40mm piece of rebar, which will serve as the R8 spindle, which fits into this machine, which kind of looks a bit like this. You've got the driving keyway and a bit of a taper at the bottom, so we'll be re-replicating that out of the rebar. And then I've got this 20mm-ish steel flange of some sort, which will serve as the actual body of the fly cutter. So I think to begin with, I'm going to trim a bit of this down to just a bit longer than we actually need. Cut these sides off so I can fit it into the lathe a little bit better. And yeah. So you've just seen me chuck this part up in the lathe, and I've cut it to size, a little bit bigger than I actually need, and I've put it in the lathe as best as I can. You see me put the dead centre in the back, and that's just going to give this overhanging material a little bit of extra support when we're machining it. But just to show you what we're making again, it's going to be this part here. It's just going to be this portion here, and this is going to be the spindle, the R8 spindle that's going to fit into the machine taper. And we'll machine this keyway in a bit later on. But at the minute, I just want to get it to the rough size, and then we'll have a look at doing the rest. But to begin with, I'm going to turn this side down about that much, and then I'll flip the part around, turn it down to the same size, just so we've got a nice solid round piece of bar. Right, so I've just turned this part around and chucked it up in the lathe. I'm going to use this end drill and drill a hole in like I did before, and then come in with the tailstock to support the end of the material, and then we'll turn the rest of it down to size. Okay, so I'm back over at the mill, and so far we've managed to turn down the spindle into its rough dimension. The next step really will be to face this plate on both sides and then bore a hole in the centre for this spindle to sit into. Now I have left a small collar around the side of this spindle, and that is so when I do bore a hole in the centre of this plate, I've got a collar to push it up against, and it will try and keep everything a bit more level and a bit more steady. And the reason why I actually haven't brought this down to its final dimension yet and put the taper on it is because when I do decide to weld it into this plate, the heat from the welder is most likely going to distort it and bring it out of place a little bit. So I'll do the welding first, put it in the lathe, and then bring this spindle down to its final dimension so it fits in the chuck of this machine. And yeah, that's basically it. But to actually be able to turn this plate down in my lathe, I'm going to need to use this independent 4-jaw chuck, which luckily fits in all 4 of these bolt holes in this plate. Now eventually I am thinking about getting rid of all these bolt holes, or I am definitely getting rid of these bolt holes. So to do that, once I've welded this shaft into the centre of this plate, I'll then put the shaft side into the lathe, and that will give me a chance to bring down the outside diameter a little bit just past these bolt holes. Okay, so these two parts are very close to done now, and I'm relatively happy with the finish that I got, and I'm very happy with the fit that I got as well. It's a very nice snug fit. So on the back side of this plate, you would have seen me put a chamfer on the inside of this hole, and that is just so when this shaft is pushed all the way through, it gives me a little gap to weld into, and that's just going to give that weld beam a little bit more strength. So once I've done that, I'm going to put this plate back into the lathe, and I'll bring this shaft down to its final dimension, and I'll put this taper on the bottom, which will allow it to fit into this machine. Okay, so now we've welded the spindle into the base plate, the next thing to do is going to be to turn down this end to the right size and to copy this taper onto our part. Now this taper is absolutely crucial and it needs to be perfect. So in order to do that, I'm going to copy a taper that's already been made. Now I've got this ER32 collet holder in the lathe, and I've put my dial gauge into my tool post holder. Now what I'm going to do is I'm going to bring the cross slide in just until the dial gauge touches the taper, and I'm going to turn the top slide a little bit until I think that the angle matches roughly, just by eye. So I think we're probably getting close there somewhere. Now, if we move the top slide in and out, you can see that that dial is still moving up and down, which tells me that we haven't got this cross slide to the correct angle yet. So if we move it a little bit more, eventually you see we've got it there. It's barely moving now. It's still moving about 0.5 millimeters, or that's 0.05 millimeters, sorry. But eventually we will be able to move this top slide to a certain angle which will meet this angle, and then this dial gauge will read 0 when it does. So I'll do that now and we'll come back. Okay, so now I've got all this dialed in, you can see that when I move the top slide forwards and backwards across this taper, the dial gauge doesn't move at all, it reads 0, which tells me that this top slide is at the exact same angle as this angle here, which means we can now take the dial gauge out of the tool post holder, put a tool in there, and transfer this angle to our part. Okay, so you can see here that even though the base plate is running perfectly true, the spindle isn't. Now, this could have been caused by a load of different problems. Maybe there was some inconsistencies in the borehole, or maybe when I welded it, it wasn't welded quite level, or the heat from the welder could have distorted it. Either way, it's not running true. So this is the exact reason why I didn't bring it down to its final dimension to begin with. But now it's been welded into place and it's not going to move again, I can redraw the hole at the back for the tail support and then come in and just take some light passes just to bring it down to its final dimension, and then we can put that taper on the end. So you see me drill a hole in the back of this spindle. Now this hole is going to be for the drawbar. So in the bore of most mills, you have a drawbar a bit like this that goes directly through the centre bore of the machine. Now when you put the R8 spindle into the bore of the machine, this drawbar screws directly into the back and pulls this thort up into the machine, which keeps everything fixed nice and steady. And in fact that's what this taper is for. So most of this sits on this taper when this drawbar pulls it up into the machine. But this bar is actually 11mm with a 1.25mm pitch thread, which is a small pitch thread for the size bar it is. So unfortunately the tap I've got is either too small with the pitch thread that I need, or the boring bar that I use for creating internal threads is too big. So how do I actually make the threads on the inside of this? This is fully finished now, and I'm very happy with how it's turned out, to be honest with you. If I was to say anything though, the cold bluing process could have gone a little bit better. I tried to get all the grease off, but it looks like some still remained on the sides, and the cold blue didn't quite get it all. But all in all, yeah, it's turned out really nice. And I did decide to keep these bolt holes eventually. I thought, why not? There's no point turning it down past the bolt holes and just wasting material, so I did decide to keep them. And at the last minute I added this little guardrail. I thought, just for safety purposes, I'll add this little guardrail, and I put this tool carrier in as well, which just essentially carries the tool. This is an 8mm high-speed steel tool from the lathe, and this is a 12mm carbide insert tool from the lathe, and they both fit in there quite nice, and that just pops in there. So yeah, I mean, the question is now, does it actually fit in the mill? So the answer to that question is yeah, it fits really well. I'm quite pleased with that, actually. So I guess if you're still asking that question, what is a fly cutter? I guess it's time to show you what this thing can actually do. So I think that about wraps everything up. I mean, this fly cutter just speaks for itself. I mean, it's left an amazing finish on this 7-inch wide plate. I mean, I'm very impressed, to be honest with you. Not to mention, it's about 50 times bigger than the first one I made. Thanks for watching.